Okay, continuing section 4.3 with our examples on solving algebraic equations using the addition property. What we have going on in this last example, I finished the check right here. So we're going on to parts B, C, D, E, and F. And hopefully you've worked these on your own so you can see if you got them correct. So we have here to change this to addition of an opposite. So now we can say I want to add the opposite of negative 7/8, which adding the opposite is a positive 7/8. What I do to the left side of the equation, I will do to the right side of the equation. I'll put my equal sign in to show that. Draw my line here. And then what I have here is showing what it's going to be equal to and for the equivalent equation. So my variable is x, and a negative number plus a positive number, that makes 0. We don't write that down, that's the identity property. And 3/8 plus 7/8, which gives me 10/8, and I made it easy on you there with common denominators. This could be more complicated if we had unlike denominators. And I'll divide both the numerator and the denominator by the GCF of 2, which will give me a 5/4. And because this is just a number, I am going to change it into a mixed number, 1 and 1/4. And so that'll be my final answer, that x is equal to 1 and 1/4. Moving on to the next problem here. Again, I want x to stand alone, so I'm going to need to add the opposite of 3.5. So I'll be adding negative 3.5. What I do to the right, I do to the left, and that's going to create my equivalent equation. My equivalent equation is going to look like x equals, and now I have to subtract 3.5 and 1.7. So if this is the bigger one, 1.35 minus 1.27. And I'm going to have to put the 0 in here to hold the place. I'm going to have to do borrowing. And then 10 minus 7 is 3. 4 minus 2 is 2. 3 minus 1 is 2, and this is going to be a negative number because the bigger one was negative, so negative 2.23 as my final answer. Moving on to the next problem. We have actually moving of the variable term this time, and the addition property still does that. So this time you see the x's are on different sides, so I want to get those x's together. So I'm going to move them to the side where the x's are bigger, and so I'm going to move this 2x. So I'm going to have the opposite of a 2x, so I can make it magically disappear from this side. And what I do to the left, I do to the right. And then I'm going to add those things. So 3x minus 2x, which is just one single x, equals 2x plus negative 2x, which is 0, and we won't write it down because that's our math magic, and that's equal to 9. So there's our solution for that one. Now this next problem, your book puts these in section 4, but I'm going to do them as a part of this section because it's really just using this addition property twice. One time to get the x's together and one time to get the constants together. So I'm going to start here with add the opposite. And then the first thing I'm going to do is I'm going to get the variables together. So I want this 2x to go over to be with this 3x. So I'm going to add the opposite of 2x to both sides. So negative 2x to both sides. And then I'm going to do that step so that you see this one step at a time. So 3x plus negative 2x, which gives me x, and then plus 9 plus 0, which is 9, equals 2 plus negative 2, which is 0, and then plus a negative 4. And then I see I need to get the numbers together. So I'm going to make this 9 disappear and make it reappear over on the right side. So I'm going to add its opposite to have that happen. What I do to the left, I must also do to the right. So now I'm going to get my new equivalent equation. X on the left side is equal to a negative 4 and a negative 9, which is a negative 13. And that's my solution on this one. And then finally, my last one, doing that one more time, I'm going to get the x's together. The 5 is bigger over here this time, so I'm going to take the x's to the right-hand side this time. And so I'm going to add the opposite of 4x to both sides. And now I have negative 4x and 4x, which is 0. I won't write that because I don't need to know that. So 3 plus 0 is 3. 5x minus 4x, which is just simply an x. And then plus a negative 9. Now I want this negative 9 to go over here, and I'm going to add the opposite to both sides. That's a positive 9.